In this short video, I'm going to give you an overview of the CrystalMaker software package, which is available for both Windows or Mac OS X. CrystalMaker is a modeling program and crystal structure visualization aid, which is quick and easy to use and lets you build any molecular or crystal structure. We can then output those structures as either graphics files or video files for use in reports or presentations and so on. Don't worry about how my software is set up here. I'm using the Mac version, and yours may look a little bit different, but all of the same functionality will be available. To start with, I've opened up a crystal structure file for gypsum, calcium sulfate dihydrate. Before we begin though, let's have a look around the user interface itself. The main area where we see the crystal structure visualization is called the graphics pane, and here we can view and manipulate the crystal structure that we're working on. Over on the right hand side we have the sidebar, and in here we've got two different features. At the top we have the site browser, where we can view all of the atoms that are currently in our crystal structure, and we can change their color either globally for all atoms, or we could just change one color for one particular atom. And we can also choose whether the atoms are visible, whether they're labeled, and the size of the atoms. At the bottom we have the notes pane, where we can enter rich text giving a description of the crystal structure or to help us keep progress of our work. In this case we can see this crystal structure for gypsum and a description down here in the notes pane for the crystal structure and a reference to the original work. At the top we have a customizable window toolbar with links to most of the common operations that you'll need to use. This is customizable by right-clicking and then pressing Customize Toolbar. Over on the left-hand side, we have this floating tools palette, which contains many important tools for manipulating and measuring the crystal structure that you're working on. For example, at the moment we're on the arrow tool, which lets me point at things and click on them, and information about that particular feature will appear as a tooltip. We can also click on the hand tool, which will allow us to manually move the structure around, rotate in different directions. Next up, we have the lasso tools over here, which are really useful if you want to multi-select atoms or polyhedra within your crystal structure. For example, we can use the polygon selector tool here to just draw a circle, a lasso around our layer of polyhedra at the top of our crystal structure, and then the right-click menu will let us hide the selected atoms. Next up, we have distance and angle measuring tools, which can be really helpful in measuring bond lengths, for example, or bond angles. We can go from standard to full screen, and we also have tools here for scale and centering, which can be quite handy, and also for zooming in and out of the crystal structure. Finally, down at the bottom here, we have some automated tools to help us rotate by set amounts. So you can choose a particular degree here, so for example 5 degrees, and then rotate using the arrows so you move in set specific distances. The last part of the user interface that we need to discuss is the menu bar along the top here. This contains links to all of the operations, including those in the window menu bar we've looked at already, plus many more. For example, if we wanted to create a new crystal structure using information that we had perhaps obtained from the International Crystal Structure Database, the ICSD, or from the literature from a paper that we'd found, we would go to File, New, and Crystal. In here we can enter the space group for the material. It's important that the formatting is correct, so you can see here that there's a space in between each of the operators. You can even just put in the space group number. We can also then browse to other space groups if we're looking for a particular setting. We can then put in the lattice parameters, A, B, C, alpha, beta, and gamma, and then we can add in atoms, giving the Cartesian coordinates X, Y, Z for each of the atoms that we add. I'll go back to the gypsum crystal structure. From the file menu, we can also import data. So for example, if you've been doing a reap belt refinement using GSAS, or if you've been accessing the ICSD and have a CIF file, a crystallographic information file, you can import those directly here as well. We can save our work, and we can also export here to give us graphics files and movies and even 3D files. But bear in mind, If you create a 3D file, you'll need to make sure that your audience has 3D glasses with which to view it. The Edit menu lets us edit all the crystal structure information. So for example here, we can go Edit Structure, and we can edit all of the atom parameters and view them all from this particular window. Any you want to edit or change, you just double click on, and then you can edit at your heart's desire. You can also go Edit Bonding and view which atoms are bonded to each other. By default, CrystalMaker does a pretty decent job at this, but it's always worth checking that it's bonded the correct atoms together. And so we can see here it's created bonds between calcium and oxygen with a bond max of Bmax and maximum bond length of 2.7025 angstroms. The final column is really useful as well because this gives us information about the coordination environment. So for example here we can see that calcium is bonded to 8 oxygens, and each oxygen is shared between 1 or 2 calcium atoms. Next we have the selection menu where we can select particular atoms and change reset colors and styles and so on. A key menu is the model menu here. At the moment you can see we're viewing this crystal structure in the polyhedral view, and that's why in our crystal structure visualization we see the structure as polyhedra. If we were to choose ball and stick, as is often the default, you can see how that crystal structure would look. And you can see for gypsum it's very complicated. We see more, but it's much more complicated. So that is why in this case I look to use polyhedral views instead. Much more simple. That said, it is a representation and obviously we are losing some information. If you were looking at a simple crystal structure, something that was fairly densely packed, for example the rock salt structure as evidenced by some alkali halide materials and other materials, you might use balls and sticks because with the density of the structure you would lose a lot of information and mask a lot of information by filling the whole space with polyhedra. But for a complex crystal structure like this gypsum, the balls and sticks view is just too much, and it's much more useful to view it as polyhedra instead. The polyhedral view highlights the packing, the layering arrangements, for example. Another important feature of the model menu is right at the bottom, the model inspector. I also have this shortcut over on my window menu bar for the same thing. The model inspector lets us change how the visualization is made. So at the start we can choose how the atoms are represented, and so we can see our calcium and our sulfur atoms here are represented as solid polyhedra. We could also change this to the translucent plus spheres plus bonds, which can look quite effective. I'm going to change that back for now to rendered solid. You can see the red X's indicating that in this visualization the hydrogens and the oxygen atoms are not shown. We could easily change these back to spheres, for example, if we wanted to. It's all about the story that you're trying to tell. We can change the color and style of the bonds, whether or not a unit cell is shown, and how it is shown, with the dashed lines, solid lines, and the weight of the line. We can edit the labeling format. At the moment they're all invisible, but we could also locate them on any of 8 different orientations next to the atoms. We can change the background, so the default is always for the black. That's not very good if you're trying to print out a picture. If you're trying to write a report, put a picture in of your crystal structure, it's probably going to be better to have a white background, for example. We can change the lighting of the model, so whether they're lit from the top left as they are here or from another direction, for example. And also we can add in some depth fading, so we can make things at the back of the model start to disappear. That can be really useful if you're looking at a big crystal structure, but be careful not to overuse that kind of thing. Next, we have the transform menu. This has a really useful thing in here called set range. I also have this shortcut in my window toolbar here where I can access the same thing, set range, a bit more quickly. This allows us to change the limits so that we can expand and contract to show more or less of the crystal structure. The final thing I want to show you is this measure menu. Again, from here we can do many of the measuring operations, but we can also click on this powder diffraction menu option, which will let us open up Crystal Diffract and show us the diffraction pattern for the crystal structure that we're looking at the moment live as it is in the software. So we can reflect any changes that we've made to it, for example, and see what effect they would have on the crystal structure. So I'm going to go ahead and do that now. As you can see, Crystal Diffract launches automatically, and by default it has shown us the diffraction pattern for our gypsum. So as it is in CrystalMaker at the moment, this is what the diffraction pattern would look like for that crystal structure. Over on the right here in the sidebar, we've got the Format tab by default. This lets us change the scale of the axes and the font sizes used for the text and so on. And in the parameters, we can model different types of experiment. If I click on Instrument here, you can see that it's calculating an X-ray diffraction pattern. We could also choose neutrons if we wanted to. We can change the wavelength here. You can see it's picked up automatically the most common wavelength, which is for copper X-rays. And it's got the wavelength for copper X-rays in here. And also some basic instrumental peak shape parameters. And so it's modeling the peak shapes here using a Gaussian peak shape. We could look at particle size and strain effects and see what impact they would have on the peak intensities and the peak shapes. And you can see those broadening as we get to a very small particle size. And we can also do the same to model changes in the lattice parameters and see what impact those would have on the peak positions. This is all very helpful, useful stuff. From the file menu here, we can also add in a new pattern, so add in another simulated pattern, or even some observed data. If you wanted to add in your own actual experimental data, you could do that here. At the bottom, we have the option to save and then also to export. And so we can export the graphics as we've got this diffraction pattern. And so again, that would be handy if you wanted to put in a diffraction pattern into a report, for example. So hopefully this video has given you some indication of the usefulness of CrystalMaker and also Crystal Diffract, and how you can use these to visualize crystal structures and get a better understanding of the diffraction patterns that materials can give rise to. The software is capable of much more than I've shown in this short video, and I would encourage you as you're working just to save your project every now and then have a play with the software, try different things and see what they do. And hopefully you will enjoy using CrystalMaker and find it useful in your research and in your learning.